with the new topic, that is the adder and the subtractor in this case. Okay, so means till now what we have studied in the digital electronics is the logic gates, K maps, and Boolean expression, Boolean algebra, and all. And before this, we have also studied the what are the combinational circuits, basic of the combinational circuits, fine, basics of the combinational circuits. And in the after that, after studying the combinational circuits, we have studied the various types of the various types of the combinational circuits. What we have studied the multiplexers, fine, we have studied the multiplexers. Then in the multiplexers, we have studied about 2x1 marks, 4x1 marks, analysis and the designing of the multiplexers. We have studied these many things till now, fine. So in the combinational circuit part itself, what we are doing now, we will be studying the adders and the subtractors. So now we will be studying the adders and the subtractors part, fine. Okay, we will be studying the adders and the subtractor part. Okay, so before we begin with the adder and the subtractor part, some basic thing I want to explain it to you. Means whenever two numbers are present, fine, whenever two basic numbers are present, that is 1 and the 1, fine. So what happens if we are doing the addition part, then 1 plus 1 will give us 2. Okay, so this is basically in the decimal case. So this is basically in the decimal case, fine. Okay, now if we are doing the binary operation, so what we would get, 1 plus 1 will give us 1 0. So this is basically the binary. So this is basically the binary, fine. Okay, now in the next case, 1 plus 1 can give us 1 also, and this is in the case of the logical operation, and this is in the case of the logical operation. This is in the case of the logical operation, fine. This is in the case of the logical operations, okay, that we are performing with the help of the logic gates, fine. Okay, so whenever two numbers are present, 1 plus 1 can give us 2 in the decimal, 1 plus 1 can give us 1 0 in the binary, and 1 plus 1 can give us 1 in the logical operation case, fine. Okay, now coming to this thing, in the adders and the subtractors, we would be studying about the addition and the subtraction part. Okay, so we would be studying about the addition and the subtraction part, and what basically we would be we would be performing this particular binary operation. We would be performing this particular binary operation, fine. Now when we are doing 1 plus 1, what we will get, we'll get 1 0. So 0 would be here and 1 would be carry forwarded, fine. 1 would be carry forwarded, fine. Now when we would be performing next 1 plus 1 plus 0, then what we would get, we would get double 1. So 1 would be here and 1 would be carry forwarded. Okay, now 1 plus 0 plus 0, what we will get, we will get, okay, now okay, sorry, just a second, this thing I have done, and just okay, now consider this example again. Okay, so 1 plus 1 would give us 1 0. So 0 would be here and 1 would be carry forwarded, fine. Now 1 plus 1 plus 0, it would again give 1 0. Okay, so 0 would be here and 1 would be carry forwarded, fine. Now 1 plus 0 plus 0, it would give 1. Okay, it would give 1. Okay, now the carry would be 0 in this case, as no carry is there. So 0 plus 1 plus 1, what it would give? 1 0, fine. So this would be the final answer that we would be getting. Okay, now what we can see is, when two bits are added, fine, this operation is being performed by the half adder. When two bits are being added, then this operation is being performed by the half adder. Okay, now here what is being done, here in this particular case, 3 bits are being added, so this particular operation is being performed by the full adder. This particular operation is being performed by the full adder. Fine. Okay. And these all are the carry. These all are the carry that we have got. Fine. These all are the carry, and this is also the carry. Okay. So this is basic. So this is the whole operation of the binary addition, you can say, and this whole process will be called the binary parallel addition. This whole process would be known as the binary parallel adder. This whole would be known as the binary parallel adder. This whole would be known as the binary parallel adder. Why parallel adder? Because it is performing the operation of additions parallelly. Means it is simultaneously performing all the additions. Fine. And why binary? Because it is giving the output in the binary form. Fine. Okay. So this basically is known as the binary parallel adder. Fine. Now, so what we have understood it till now, we have understood it that what half adder does. Half adder basically adds two 1-bit numbers, and what full adder does, full adder adds three 1-bit numbers. Okay, so what is the functionality of a half adder? Half adder adds two 1-bit numbers, and the full adder adds three 1-bit numbers. Okay, just give me a second. So what half adder does, it adds two 1-bit number, and what full adder does, it adds three 1-bit numbers. Fine. And what does a binary parallel adder does? Okay, so it adds two 4-bit numbers or two n-bit numbers. Fine. What is the functionality of the binary parallel adder? So it basically adds two 4-bit numbers or two n-bit numbers. Means how means whatsoever bits of the numbers are present, it would add those two numbers and give us the final output. Fine. So this is the basic of the half adder, full adder, and the binary parallel adder. So in the summary, we can say half adder adds two 1-bit number, full adder adds three 1-bit number, and binary parallel adder adds two 4-bit number or two n-bit numbers. Fine. So this is the basic functionality. Okay. So this is the basic functionality of binary parallel adder. Fine. Now, next coming to the half adder thing. Fine. Now next coming to the half adder thing. Okay. So in the half adder thing, this is basically the block diagram of the half adder. This is basically the block diagram of the half adder. Okay. So two inputs are being present, A and B. Okay. So two inputs are being present, A and B. So in case of the half adder, what we would be getting? We would be getting one output as sum and the other output as carry. Okay, one output as sum and the other output as carry. Fine. So these things we would be getting in the half adders. Fine. Now, when two inputs are present, so based on these two inputs, how many total possible combinations would be present? So 2 to the power 2, that is 4 combinations would be present. That is 4 combinations would be present. Okay, total 4 combinations would be present. Okay, total 4 combinations would be present. Fine. Now these 4 combinations are being written over here. First is 0 0, next is 0 1, then 1 0 and 1 1. Okay, so these total 4 combinations of input would be present over here. Fine. Now what is the thing that we are getting? We are getting one as sum and the other is carry. Fine. When we are adding 0 and 0, what sum we would be getting? We would be getting the sum as 0 and the carry also as 0. And when we are taking the inputs as 0 and 1, what we would be getting? We would be getting the sum as 1 and the carry as excuse me. Okay. I would be explaining this thing again. Now when total 4 combinations are present here, fine. So when the input is 0 0, what we would be getting? We would be getting the sum as 0 and the carry as also as 0. Now in the other case, in 0 1, so 0 plus 1 would give sum as 1 and the carry as 0. 1 plus 0, what it would give? 1 plus 0 give sum as 1 and carry as 0. Fine. And 1 plus 1, what it would give? It would give 1 0. So this would give us 1 0. So this would be the output and this would be the carry part. Right? This would be the carry part. Okay. So this is the final truth table that we are getting over in this case. Fine. So this is the final truth table that we are getting over here in this case. Okay. Now, if we observe uh, the sum part, okay, if we observe the sum part, so this is the basic functionality of the a dot b. Okay, so a XOR b, sorry, sum is the basic functionality of the a XOR b. Okay, so sum can be written as a XOR b. Okay, because sum is after looking at this output of the sum, we can see that it is the basic output of the basic output that we get in the XOR case. Fine. So sum can be written as a XOR b, and the carry can be written as a dot b, and the carry can be written as a dot b. Fine. So sum can be written as a XOR b, and the carry can be written as a dot b. Fine. So this is the basic output expression that we are getting. Fine. So this is the basic output expression that we are getting. Okay. So I would write down this output expression over here. So sum is a XOR b and carry is a b. Fine. Okay. Sum is a XOR b and the carry is a dot b. Okay. Now if we want to means make the diagram is this of this particular half adder, then we can also make the diagram of this particular half adder. So what would be the diagram? So, XOR and A XOR B, and now A dot B. Fine. So this would give us the sum part and this would give us the carry part. Okay. This can be put it into a particular block. Okay. So this is the basic diagram of the half adder. So this is the basic diagram of the half adder. Fine. So I hope that you must have understood it till now. Okay, in half adder what we are getting for the sum expression is a XOR b, and for carry the expression is a dot b, and this is the logic diagram of this particular half adder. Fine. Now